Okay, look here, we have an object here. It's going to do a circular path at a constant speed. So what is the acceleration of this object? So you may say, you said constant speed, right? If the speed is constant, shouldn't the acceleration be 0? No, the acceleration is not 0 because even though the speed is the same, the velocity is changing. Yeah, velocity is a vector. So if its direction is changing, then the acceleration cannot be 0 because acceleration is the rate of change of velocity, not speed. So in that case, what would the direction of the acceleration be? Let's make a guess. Maybe it's along this direction, yeah? Maybe, yeah? But something doesn't look very right here. Okay. Why not we resolve this acceleration into two components? So there's the tangential component. Tangential, right? Because it's along the tangent, yeah? And the other components will be the centripetal component. Why centripetal? Now, the word centripetal just means towards the center of a circle, right? So the center of the circle is here. So this direction is called the centripetal direction. So if I resolve my acceleration into the tangential and centripetal components, it will look something like this. Get it? So this acceleration, I resolve it into these two components. Now let me animate this thing for you. Now surely you can see that something is very wrong. The acceleration can't be like this. Something is very wrong. Why? Because if we have this acceleration along this direction, how can the speed remain constant? It should go faster and faster, right? But I told you that this thing is moving at a constant speed. What does that mean? So if you have something moving in a circular path at a constant speed, then we know for sure that its acceleration is not 0 and is in the centripetal direction. So you have learned something quite profound, yeah? So from now on, when you see uniform circular motion, you must realize that the acceleration is not 0. But since the speed is constant, then there cannot be any acceleration in the tangential direction. That means all the acceleration can only be in the centripetal direction. This is called the centripetal acceleration. The centripetal acceleration changes the direction of your velocity. It doesn't change your speed. Get it? Wow, we're quite clever, huh? So we have already figured out that the direction of the acceleration is in the centripetal direction. But what about the magnitude? For this, you are given this formula. Centripetal acceleration is v squared over r, which is also equals to r omega squared. The derivation of this formula is not in the syllabus, but I've made a video to explain this, so you can watch that video if you're interested. Okay, let's have a mass moving along this curved path. So at the instant when the object's at this point, it has this tangential velocity, right? So do you know the direction of the acceleration at this point? It's towards here, right? Why towards here? Because the center of the circle is here. So the centripetal direction is here. So at this point, the object is experiencing a centripetal acceleration along this direction. What about when the object is here? So when the object is here, the center of the circle is here. So the centripetal acceleration is along this direction. Get it? So why did I draw this acceleration 3 times this acceleration? That's because this is a much tighter turn. Yeah, much tighter turn. So the radius of curvature here is 1/3 the radius of curvature here, which makes the acceleration roughly 3 times. Now the A-level syllabus is usually about uniform circular motion, and it's usually a perfect circular path, a circular path with a fixed radius. So maybe we should concentrate on those scenarios. So here I have 2 objects. This one is going to do this, this one is going to do this. So the radius of this circle is 2 times the radius of this circle, right? So if they are moving at the same speed, who has the larger acceleration and by how much? Yeah? So go figure it out. When you're ready, then come back to me. Okay, ready for the answer? This guy has 2 times the centripetal acceleration as this guy. How come? Because they have the same v, right? So this one has half the radius, and therefore it should have 2 times the acceleration. it should make sense to you because you can see that this guy is, the direction is changing much more quickly compared to this one. This one, the velocity is changing at a much leisurely pace. Yep. Okay, what about these two? So same radius this time, but this one is moving at double the speed. So who has the larger acceleration and by how much? Ready for the answer? Okay, so this guy has 4 times the acceleration. Why 4 times? Because they have the same radius r. So if you have 2 times the velocity, because of the v square, yeah, because of the square, you have 4 times the acceleration. And again, it should be quite intuitive because you can see this one, the velocity is changing so quickly. Yeah? The rate of change of its velocity is much faster compared to this one. This one, the velocity is changing at a much slower rate. Alright, that's all. Ta-ta!